Assalamualaikum. Welcome to my channel Mathematical Room. So in our today's video we are going to prove the trigonometric identity that is given in front of you as left hand side. We have to prove is equals to right hand side. So left hand side is given as cos theta plus sine theta divided by cos theta minus sine theta plus cos theta minus sine theta plus divided by cos theta plus sine theta. And after simplifying the left hand side, we will prove that the left hand side is equal to right hand side, as the right hand side is given as 2 over 1 minus 2 sine squared theta. So let's start with this question by taking the left hand side. So left hand side I have written over there. So if you see, the denominators of the left hand side are cos theta minus sine theta into cos theta plus sine theta. So by taking the LCM of these two fractions, so the LCM will be cos theta minus sine theta and cos theta plus sine theta. So by using the trigonometric identities and kind of algebraic identities, we are going to solve, we are going to prove the left hand side is equal to right hand side. So by taking the LCM of these two fractions, after taking the LCM, you have learned a lot in your previous classes that LCM will be divided by the first fraction of the denominator of the first fraction. So this cos theta minus sine theta will be cancelled with this one, and the remaining cos theta plus sine theta will be multiplying by numerator of the fraction. So if you see that cos theta plus sine theta will be multiplied by cos theta plus sine theta, so that can be written as cos theta plus sine theta whole square, because these are two same things that are multiplying with each other, and they will become in the squared form. So after that, the plus sign and this denominator will be divided by this LCM. So cos theta plus sine theta will be cancelled with cos theta plus sine theta, and the remaining cos theta minus sine theta will be multiplying with this numerator of the fraction. So when cos theta minus sine theta will multiply with each other, so that will become cos theta minus sine theta whole square, because these are the two same things multiplying with each other, so they will become in the squared form. So now in our next step, we are going to little bit more simplification. So that will become as it is cos theta before that, I'm going to tell you about the algebraic identities that we are going to use to solve this expression. So the couple of algebraic identities that we know that about is a square, or you can say that a plus b square plus a minus b square is equals to 2 into a square plus b square. So if you remember that in my initial lectures about the algebraic identities, we have learned about these kind of formulas. So I'm not going to explain over here, that just going to write the straight away the algebraic identity. So the first algebraic identity we are going to use is a plus b whole square plus into a minus b whole square always equals to 2 into a square plus b square. So if we simplify this algebraic identity by taking the left hand side, and when we open the square, so after simplification we get the answer 2 into a square plus b square. And the second identity equals to a plus b into a minus b always equals to a square minus b square. So that's the second identity we are going to use in this question. So a plus b into a minus b always equals to a square minus b square. So if you see that this left hand side is like this side. So here we are using in algebraic identities a and b as a variable, a and b as a variable by taking, if you see in this trigonometric identities, that you can see that cos theta plus sine theta, or over here a plus b, means if you suppose that this one is a, this one is b, or cos theta is a and sine theta is b, so a plus b plus into a minus b sine cos theta minus sine theta. So that's the given form of this algebraic identity. So we can write this thing as equals to 2 into square of first plus square of second. So first is cos theta, second is sine theta. So we can write this whole thing as 2 into square of first, so cos square theta, plus sine square theta. So if you see that the cos is a and sine is b, so that can be written as 2 into square of first plus square of second. So 2 into square of first is cos theta and square of second is sine theta. So that whole thing can be written in this form, 2 into cos square theta plus sine square theta divided by if you see that this second identity, that first plus second into first minus second always equals to square of first minus square of second. So I can write this thing as square of first minus square of second. If we say that this one is a, this one is b, this one is a, this one is b, so a plus b or a minus b into a plus b or a minus b always equals to square of first minus square of second. So we can write this expression as square of first cos square theta minus square of second sine square theta. So that's the most important step that we have to understand, that we have used the algebraic identities in this given conditions, and after using the algebraic identities, that all the expression can be written in this form. So now if you see that in algebraic identities, we know that cos square theta plus sine square theta always equals to 1. So we can write 2 into 1 divided by, so now we have to change the right hand side into sine square theta. So we will change the cos square theta into sine square theta by using this identity. So what can be the cos square theta equals to, if we take this sine square theta on the other side of the equation, so that can be written as 1 minus sine square theta. So now we have put the 1 at the place of cos square theta plus sin square theta, and in the denominator we are going to put the value of cos square theta, where cos square theta is equal to 1 minus sin square theta. So 1 minus sin square theta minus this sin square theta. So this 1 minus sin square theta we have put it at the place of cos square theta, where cos square theta is equal to 1 minus sin square theta. So this 1 minus sin square theta has become at the place of cos square theta, and this minus sin square theta we have written as it is. So 2 ones are 2 divided by 1, and minus sin square theta and minus sin square theta will be added with each other, so we can say that 1 minus 2 sin square theta. So if you see, after the simplification we have got the answer that 2 over 1 minus 2 sin square theta, which is equals to, at the beginning of the question, 2 over 1 minus 2 sin square theta. So which is equals to the left hand side. We can say that left hand side is equals to right hand side. So left hand side was this thing, and by taking left hand side, by using the trigonometric identities and algebraic identities, we have solved, or we have simplified this left hand side, and after simplification, step by step, we have got the answer 2 divided by 1 minus 2 sin square theta, which is equal to right hand side of the given question. So hence we can say that left hand side is equals to right hand side. So that's the answer, that we have proved that if we simplify the left hand side, then we got the answer which is equals to right hand side as 2 over 1 minus 2 sin square theta. We have proved that left hand side is equals to right hand side. So that's the question. We have proved that left hand side is equals to right hand side by using some kind of trigonometric identities and algebraic identities. So hopefully you will understand that how can we solve this kind of question. After that, we will take 1 or 2 more examples in our coming lectures, and then we will change the topic and start with another interesting topic. So inshallah, I will see you in my next video. So please don't forget to subscribe my channel Mathematical Room, and press the icon button, bell button, that you can straight away receive the new uploaded videos. So inshallah, I will see you in my next video. तब तक के लिए इजाज़त दीजिए। खुदा हाफिज़।